Are you paying attention? I'm watching you.
Hi, this is Mr. Moreno. Okay, I'm here. And this is for past 6. I forgot to write that down. Chapter 3.3, and this is about sedimentary rocks. So what are sedimentary rocks? You might have read about it, but didn't really believe it. So that's what this video is for, to make it maybe a little bit simpler. So there are little bits and pieces of rock. They can be shells or they can be sand. But as they get deeper and deeper in the earth, and after lots and lots of time, they start getting packed. The pressure of other things on top of them, or the wind, or the water, start pushing them together. So one way you can think about this is if you have a cardboard box. I don't know if you've ever had a cardboard box, but if you let a cardboard box sit outside for a long time, the longer you leave it sitting, it's harder to move. Why? Because the box starts sticking to the floor. It's a strange effect, and you don't need to know why that happens yet. But you should know that the longer you let something sitting, it starts sticking to each other. Or we can call that cementing to each other. Same thing happens with rocks over millions and millions of years. So these little itty-bitty pieces of rock start clumping together and get pushed together into this rock that doesn't really have a good shape. But after more thousands and millions of years, wind and water start smoothing out this rock and makes it smooth. So that's why you cannot really tell that this came from a bunch of different kinds of things, because it happened over millions and millions of years, so now it is smooth. And here's my example. This box, I leave it sitting outside for a long time, and now, oh, it's hard to push. All right.
Are you listening?
All right. Anyways, the other special rock that they talked about was coal. Now, it told you on page 91 that coal is a special rock that comes from plants instead of other rocks. And that is very important because if you think about it, when you're out in the woods, if you want to burn something, you burn wood, right? Or dry leaves. Dry leaves will burn. Now imagine thousands and thousands of these leaves are packed together over millions of years, or maybe thousands now, I think it takes millions, of pressure. It eventually becomes this compact little rock that we call coal. Why is that important? This is a very good fuel. It's much better than wood, right? Because this is kind of like already put together, this, think of it like gasoline. It's already put together. You don't need to gather it. You don't need to cut down a tree. It's already there. But the problem is, since this takes so many millions of years, it will eventually run out. We will run out of coal. It'll take a while, so you don't need to worry about that. It does smell bad. Okay. Now, on the next page, it told you that, I think it was on page 94 and 95, that they can show you the action of wind and water. Well, what does that mean? I'm sure all of you have seen a tree and its rings, right? I'm drawing it here. And when it's a big ring, it can be maybe a year. This is the rings of a tree. So I cut the tree in half. And if there's a big ring, like a lot of space, it means that year it grew a lot. It was maybe a very sunny year, or it had plenty of water. So we can know by cutting a tree in half what the environment was at that time. Same is true with sedimentary rock. If you cut the rock, or if you see it like on its side, for example, on a canyon like the Grand Canyon, you can see what was going on in this time, or what was going on in this time. And if there's some sort of major event here, like some sort of thick line, you know something big happened at that time. So imagine this is in a desert, but somehow when we start cutting, we find a fish. What does that tell us? That tells us that a long time ago, there was probably a lake there. And if we find something bigger, like a whale or maybe a big shark, we can assume or predict that maybe there was even a sea or an ocean there. That part used to be part of the ocean, but it is now desert. And climate does change that drastically over thousands of years or millions of years. And you'll learn that in Past 7. But you should know that by looking at the different layers of the sedimentary rock, the lower you get, it gets older. Obviously, new sand is going to be on the top, right? You're not going to have new sand in the bottom. So newer. And we can find out what happened in those times. All right.
Still watching you.
Okay, bye.